Hi, everyone. Finishing off 7.3, page 3, we have these types where these are like you have some given information and you have to find some expressions. The first thing when you start these problems is, for example, you have sine S. Draw that out so that way you can get cosine S, which you will need in the expression. So sine S, and S is in quadrant 4. I'll just do a quick sketch over here to the side. Maybe blow it up a little bit. I have S is negative 12 over 13. And then I don't know the X there, right? And so just use a quick Pythagorean theorem to figure out the X. And this is going to be 144 and 169. If I subtract the 144, I get 25. So X is equal to 5. Okay, or you can recognize that triangle, 5, 12, 13, right triangle, Pythagorean triple. So the cosine then, cosine of S is 5 over 13. Okay. The other thing we'll need, since we have sine of t, we'll need cosine of t. So maybe draw that one down here. Let's see, where is t? T is in quadrant 2. Okay. So let's draw that one over here in quadrant 2. And it's 3/5. 3/5. Is that sine? Yeah, sine t is 3/5. Sorry about all the zooming and blah, blah. Okay. So notice there's a 3, 4, 5 triangle. You can use that or just work it out. 3 squared plus x squared equals 5 squared, Pythagorean theorem. You work that out. I'm pretty sure you can do that. You're going to get 4. Okay, but just notice that x is negative in this drawing, right? In quadrant 2, x is negative, so I do have to throw a little negative on that x. So cosine of t is negative 4/5. Okay, put those aside for a minute. We have this, and we've got this. We'll need those when we actually start doing the problem. All right, so now let's go back to the problem, and we're going to do part A. So A is cosine of S plus t. First thing you're going to do is apply the identity. Cosine S, cosine t, minus sine S, sine t. So notice you have those 4 things. 2 of them are given right here, and the other 2 you just found. So plug all of those in, and then do a little calculation. So cosine of S was that 5 over 13. Cosine of t was negative 4/5 minus sine S, negative 12/13 sine t 3/5 from above. Okay. And let's see what we get when we calculate all that. So zoom in so I can write nice. This is negative 20 over 65, negative, negative, positive, and that's going to be 36 over 65. Okay. And then that's going to be 16. So we get 16 over 65. Can't reduce that or anything. Final answer. That's the cosine of S plus t. All right. Sine of S plus t will be similar. Sine of S plus t. We need the formula. It's sine S cosine t plus cosine S sine t. All right. Plugging those values in. So what do we got? Cosine, sine S was that negative 12/13. cosine t, negative 4/5. So those are negative, sorry. Cosine s, found over here, 5/13. And sine t, 3/5, right there. I'm probably making you seasick with all these zoom ins. Okay, now we've got it. Now let's simplify this. So this is going to be negative times negative positive 48/65 plus 15/65. And that's 50/63/65. Okay, we got it. Okay, now for C, there's two ways to do part C. I'm going to do it the easiest way because it's tangent. So tangent of s plus t actually is just sine s plus t over cosine s plus t. I think that's easier because you already know those two. You just found them in parts A and B, right? The sine, you just found it was 63/65. And the cosine, what was that one? 16/65. Invert and multiply, the 65s cancel, and you get 63/16. That's your final answer. Okay. Now you would have gotten the same thing had you used the, back on page 1, the identity for tangent A plus B. That one, that would work as well. Okay. So you can try that way and just find the tangent of A, tangent of B from those pictures, plug in the ratios, and it's all. It's harder that way though. So I like the easy way. Okay, and then part D just said, name the quadrant in which S plus T, where is that angle? Well, notice all of our answers for A, B, and C were all positive. The only place where everything is positive is quadrant 1. So it's got to be quadrant 1. So look at the signs of the values to make your conclusion on that. Okay, here's another one, number 12, our last one. So we're going to do this the same way. Got to find, so we're given cosine S, we got to find sine S. And we're in quadrant 1 on that one. So we'll just draw it up here, quadrant 1. And cosine S is 2/5 x over r, 2/5, right? And then the y is unknown. So 2 squared plus y squared equals, that's a 5, 5 squared. If you work that out, you'll get the square root of 21. So I know you know how to do Pythagorean theorem. Okay, so sine S then is y over r, root 21/5. Okay, put that in your back pocket for a moment. And let's find cosine t. And that's in quadrant 2. We know sine t is 3/5. That one's similar to the one above, so we knew that was -4, right, by Pythagorean triple, Pythagorean theorem. So cosine t is -4/5. Okay, now we have all the pieces that we'll need, and we can just start knocking out the formulas. So cosine S minus t is, here we go, cosine S, cosine t, plus sine of each one. And then plug in those ratios. So the cosine of S is 2/5, that was given. Cosine of t we found is -4/5. Sine S we found is root 21/5. And then sine t was 3/5. Okay, so this is going to be -8/25. And over here we have 3 root 21 over 25. Okay, and then the only way to combine that is just putting them together as one fraction. -8 plus 3 root 21 all over 25. Okay, and we got it. Funky looking answer, but sometimes they end up that way when you got radicals. B, we have sine s minus t, and I think you get the idea now. Put the identity down. Sine s cosine t minus cosine s sine t, and plug them in. Right? So the sine s was root 21 over 5. Cosine t, -4/5. Minus cosine s was the given 2/5. And sine t was given as 3/5. Okay, I'm just going to go on to the next page here. That's going to be -4 root 21 over 25 minus 6 over 25. And then all you can do is just put it together. And you've got it. Okay, there's the sine s minus t. Tangent. So again, you have two options. Apply the formula, or if you have the sines and the cosines, you can just put them in there, all right? This one, I think, because maybe, I'll do it the other way, because sometimes you don't have the sine and the cosine already, so maybe you just want to jump right to the formula. So let's just try it the formula way. We have to do tangent s minus tangent t over 1 plus tan s tan t. Okay, so I'm going to do this one just using that formula. Again, there are two ways. You could have just done sine over cosine, in which in this one you're going to have to do some rationalizing and all that, or you can do it this way. Okay, so do we have tangent s? I'd have to go back to that picture where there's the angle s. Tangent of s is y over x. So in this case, that's root 21 over 2. So I'm just looking at this picture, y over x. Y is root 21. So tangent of s, root 21 over 2. Plug that in. So root 21 over 2. Tangent t, that's this picture. Again, it's y over x. Y over x, -3/4. Right. So tangent t is -3/4. Right, and then those appear at the bottom as well. Root 21 over 2, -3/4. Okay, and you just end up with that mess, don't you? Now it's all about trying to simplify this to something that looks nice. Oh, so this is the fun part. But let's see, let's clean this up a little bit. Up top, we have root 21 over 2 plus 3/4. And at the bottom, we have 1 plus minus, right? That's a -3 minus 3 root 21 all over 8. Okay. So I have to deal with the complex fractions, and I gave you a method in the previous example before at some point that can multiply top and bottom by the common denominator, which in this case is going to be 8. Multiply top and bottom by 8 will work here. Maybe you learned that in algebra at some point. If not, you're doing it now. Okay, so distribute that 8. 2 goes into 8 4 times. So that's going to be 4 root 21 plus 4 goes into 8 2 times. 2 times 3 is 6. Right. And then at the bottom, 8 times 1 is 8. And then the 8s will cancel, 3 root 21. Okay, so that's what I've got there. which looks familiar. I mean, had I inverted and multiplied these two together, there's the numerators, right? Okay, now the last thing is I have to rationalize the denominator. Multiply this by the conjugate, 8 plus 3 root 21. 8 plus 3 root 21. Aren't you glad you paid attention in algebra on this one? Okay, a little insane, but here we go. We got to distribute, FOIL this out. 4 root 21 times 8, that's 32 root 21. Those two multiplied together, that's going to be 4 times 3 is 12. And then root 21 times root 21 is just 21. So that would be 12 times 21. 6 times 8, 48. That's the inside. And then 18 root 21. Okay. On the bottom, I'll have 8 times 8, 64. Outside, insides cancel automatically. And then -3 times +3 is a -9. And root 21 times root 21 is 21. Okay. Good thing I have extra pages. All right, keep on going. We're almost there. If you're still with me, I'm impressed. Okay. So we've got 32 root 21. 12 times 21, better get out the calculator for that one. That's 252. Plus 48 plus 18 root 21. And at the bottom, there's no radicals, so just calculate all that. 64 minus 9 times 21, which is a -125. Okay. And then anything else we can do? Well, let's see, up top, we can put the 252 plus 48, which is crazy because that's 300. That work out to be nice like that? Okay, 300. And then plus 32 plus 18, 50. Square root of 21. All over -125. And just when you thought you were done, we can keep on going, right? Because 300, 50, and 125 are all reducible by 25. So divide 25 into each one of those. 25 goes into 300 12 times, 2 times, 5 times. Right. So I just divided everything by 25, and then I've got 12 plus 2 root 21 all over -5. And typically what you do, instead of leaving the negative on the bottom, you'd probably distribute it throughout the top. So it looks better, -1 times 12 plus 2 root 21 over a +5. Or -12 minus 2 root 21 over 5. I'm calling that my final answer. I'm done with this problem. It's time to go to bed. All right, sorry that got a little long. It's the algebra that gets messy, and trying to make these things look nice in simplest form. That's where the biggest struggle is. So I wanted to do an example like that. Hope it helped. Let me know if you have questions. Keep practicing. Hang in there. You got this. All right, I'll talk to you later.